Hello students, I welcome you all within this online lecture series, rather e-class. We are continuing the topic atom. In the previous lecture, I told you people that as per the definition of the atom is concerned, I told you people that this atom is the smallest particle of the matter. The moment it is smallest particle of the matter, it takes part in the chemical reaction, and the moment it takes part in the chemical reaction, it maintains its identity in the chemical reaction. Rather, it does not lose its identity in the chemical reaction. We have discussed that very thing. Let me take this atom more forward. One more thing I would like to add as far as this atom is concerned. A single atom can't live in isolation. Can't live in isolation. What does this statement mean? A single atom can't live in isolation means a single atom does not have independent existence. For example, if I will put this drop of ink on this whiteboard, this drop of ink actually contains, it has been experimentally proved that this drop of ink contains millions and trillions of atoms. Millions and trillions of atoms. Now, it seems in naked eyes, I can say draw conclusion from this that a single atom can't live in isolation, and it becomes dead impossible for a single atom to live in isolation. Rather, when millions and trillions of atoms join with each other, and they form molecules, and they form compounds, and they form elements, and they form matter as well. And I told you people, this is not actually a single atom. This is actually more than millions and trillions of the atoms when they join and they form the matter, and they give the sixth composition to the matter. That means a single atom can't live in isolation. That means a single atom does not have its independent existence, rather I can say. Let's take this atom more forward. Let's discuss subatomic particles. Subatomic particles. This atom contains three subatomic particles. One is electrons, the second is protons, and third is neutrons. Atom contains three subatomic particles. One is electrons, second is protons, and third is neutrons. And as far as these electrons are concerned, these electrons always revolve around the nucleus. For example, this is nucleus of an atom. Nucleus of an atom. Nucleus. And this nucleus contains neutrons plus protons. They are also called as nucleons. So protons plus neutrons. And these protons and neutrons are embedded in the nucleus, atomic nucleus. And as far as these electrons are concerned, they are revolving around this nucleus. They are revolving around this nucleus in fixed shells or fixed orbits. And these shells, these are electrons revolving, having negative charge, revolving around this nucleus. And this nucleus always attracts these electrons towards itself, because there is always negative positive interaction between the positively charged proton and the negatively charged electron. And these electrons revolve in fixed orbits or shells. Now the question arises, what are shells? These are actually the shells are actually the circular parts. These are circular parts around the atomic nucleus in which electrons revolve around the nucleus. You might have heard about the solar system. As far as solar system is concerned, this is sun at the center, and all the respective planets revolve around the sun in fixed orbits or shells, and they have a fixed orbit or a shell. And this shell is also called as energy level. Energy level, this is fixed, and this is fixed, and this is also called as orbit. The moment a planet will deviate from its orbit, it will ultimately fall into the sun. The moment it will fall into the sun, the whole world will get collapsed. And same is the case with this. electron. These electrons are always revolving around this nucleus in fixed paths or fixed shells. And these fixed paths or shells are called as energy levels, and they are also called as orbits, because electrons have negative charge of minus 1.6 into 10 raised power minus 19 coulomb. And as far as protons are concerned, they have a charge of plus 1.6 into 10 raised power minus 19 coulomb. And these electrons are always attracted towards the nucleus, because electrons are having charge of negative charge and these protons are having positive charge, and that's why there is always interaction, there is always attraction between negatively charged electrons and positively charged protons which are embedded in the nucleus. As far as subatomic particles are concerned, atom contains 3 subatomic particles. Let me recapitulate this once more. This subatomic particles, one is electrons, another is protons and neutrons, and these protons and neutrons are embedded in the nucleus. They are also called as nucleons, and these electrons revolve around the nucleus in fixed orbits, in fixed shells, just like the planets of the solar system. They revolve around the sun in fixed orbits or shells. Same is the case with this. The moment these electrons will lose energy and they will fall into the nucleus, ultimately disturbing the stability of the nucleus. That means atom will lose its stability. The moment it will lose its stability, that means atom will not become stable. Same is the case with this. As far as this protons and neutrons are concerned, they actually constitute the mass of an atom. Mass of an atom. It's because of these protons and neutrons, atom is having mass. And as far as this mass is concerned, whole mass of the atom, it has been experimentally proved that the whole mass of the atom is concentrated in the nucleus. Whole mass, very important topic, and this very important point here. I told you people that whole mass of the atom is concentrated in this nucleus, because the atom is having mass because of the protons and because of the neutrons. That's why I told you people that whole mass of the atom is concentrated in the nucleus. This very important point here. Whole mass of the atom is concentrated in the nucleus. Now the question arises, if I am telling you people that whole mass of the atom is concentrated in the nucleus, that doesn't mean that electrons don't have a mass. They have a mass, but they have a meager mass, they have a negligible mass. Let me tell you people, let me make you people more clear regarding this electron. Electrons are having mass of 9.11 into 10 raised power minus 36 kg. And protons and neutrons, they are having mass 1.6725 into 10 raised power minus 27 kg. And as far as mass of electron is concerned, electron is having mass of 9.11 into 10 raised power minus 36 kg. And as far as protons and neutrons are concerned, protons and neutrons are almost having same mass, 1.6725 into 10 raised power minus 27 kg. And it has been experimentally proved that mass of proton is 1840 times mass of electron. That's why I told you people that we take the mass of electrons negligible. That means we take the mass of electrons very negligible. I mean say 0. Because the mass of the proton is 1840 times mass of electron. That means this statement shows that, and this question has been asked 50 times in CET as well as competitive examinations, that mass of proton is 1840 times mass of electron. That's why I told you people that this electron is having meager mass. Hope you people have enjoyed this. And in next lecture, we are going to study more about this atom. Have a good day ahead, and stay safe and stay at your homes. Allah Hafiz. See you in another lecture. Thank you.